The universe is vast, unfathomably so. Our solar system, a tiny corner of it, yet it holds wonders and potential perils. Consider Venus, our planetary sister, shrouded in clouds, hot enough to melt lead. But the danger we discuss today isn't from Venus itself, it comes from its companions, a newly suspected swarm of asteroids lurking in the glare of the sun. These are not just any space rocks, they are potentially city killers, a silent, unseen cohort. What does city killer truly mean? These are asteroids generally wider than 140 meters. That's about 1.5 football fields across. If an object this size struck Earth, the impact energy would be immense, far beyond any conventional weapon. It wouldn't end all life, but it could obliterate a city. It could cause regional devastation. The term city killer is soberingly accurate. It describes a specific scale of threat, one that demands our attention. Astronomers already know of about 20 such asteroids. These are Venus's co-orbital asteroids. They share Venus's journey around our star. Think of them as fellow travelers, locked in a gravitational dance. For now, these 20 pose no direct threat. Their orbits are understood, they keep their distance. But what if these known objects are just the vanguard? What if they are merely the most obvious members of a much larger, hidden population? This is where the invisible threat comes in. Many more of these Venusian co-orbitals could exist. Why can't we see them? The sun, our magnificent life-sustaining star, its brilliance can be a blinding fog. Asteroids with orbits close to Venus, especially those that don't swing far out, they can remain hidden in that intense sunlight. We search the darkness for threats, but some may hide in plain sight, masked by the very light that illuminates our world. So how do we find what the sun conceals? We use the power of the human mind, we use science. Astronomers are cosmic detectives. They use powerful tools, not just telescopes but also computers. A new study emerging from Brazil, from astronomers at Sao Paulo State University, they are tackling this very problem, trying to understand this hidden population. They are simulating the unseen, using mathematics and physics, to explore what currently lies beyond our direct gaze. Their method is ingenious. They looked at known Venusian co-orbital asteroids, specifically those with more circular, less eccentric orbits, the kind that are hardest to spot. They clone these asteroids in their computer simulations, creating virtual populations. Then they set these simulations in motion, projecting their paths forward in time, not just for a few years, but for 36,000 years. This allows them to see how orbits might evolve over truly cosmic timescales. For a glimpse into a distant future, this 36,000-year period is significant. It covers roughly 3 co-orbital cycles. What are these? Imagine the asteroids slowly drifting, relative to Venus, in their shared orbit. A cycle is about 12,000 years long. During these cycles, their positions can change, their gravitational interactions can shift. An asteroid that is currently stable might not remain so indefinitely. These long-term simulations, they help us understand that slow cosmic ballet and its potential consequences for orbital stability. What did these simulations reveal? First, let's be absolutely clear. There is no immediate danger. Earth is not currently threatened by these specific asteroids. Our planet is safe today, and for many, many tomorrows. However, the simulations did show something important. Over these vast timescales of millennia, some of these modeled low-eccentricity asteroids, they could be nudged from their current paths. Their orbits could change enough to potentially bring them onto a collision course with our own planet, Earth. How could an asteroid happily orbiting with Venus threaten Earth? The answer lies in gravity, that fundamental force. It shapes the cosmos. Earth has a significant gravitational pull. Venus does too. The Sun, of course, is the dominant gravitational player. But close encounters between smaller bodies matter. If one of these Venusian asteroids were to drift on a path that brings it near Earth, our planet's gravity could act like a slingshot, or a gentle tug that alters its course, potentially pulling it away from Venus's domain. There's a reason we haven't seen many of these. It's called observational bias. We are better at finding asteroids that have highly elongated or eccentric orbits. These are the ones that swing far from the sun and then loop back inwards, making them visible when they are further out. Asteroids with more circular orbits, especially those nestled close to Venus, they tend to stay within the sun's blinding glare. Our current detection methods are thus biased. We see the ones that are easier to see. We know such co-orbital objects exist. Venus, for example, has a companion named Zoozve. It's what we call a quasi-moon, one of these co-orbitals that stays near Venus. Earth is not alone in this either. Our own planet has dozens of known co-orbital asteroids, and we are discovering more all the time. The solar system is far from empty. It's a dynamic environment filled with these smaller celestial bodies, each tracing its own gravitational path, each a piece of solar system history. Because many of these potential Venusian asteroids are hidden, it is incredibly difficult to quantify the exact risk. How many are out there truly? We don't have a precise number, and that's the crux of the current uncertainty. Without knowing the size of the total population of these sun-obscured space rocks, estimating the probability of a future Earth impact from this specific group remains challenging. Science is a process of reducing uncertainty. This study is one step on that journey. So, what is the main message here? It is not one of immediate alarm. There is no city killer from Venus's entourage bearing down on us right now. We are discussing potential risks. Risks that unfold over immense stretches of time. Thousands upon thousands of years. The universe operates on these grand scales, and our ability to comprehend them, to model them, even is a testament to human ingenuity and our ever-expanding cosmic perspective. This research underscores a vital point: the profound importance of continued vigilance. We must keep watching the skies. We need to enhance our detection capabilities. With better telescopes on Earth and in space, developing new techniques to find these elusive objects. This isn't just about asteroids already known to be near Earth. It's about understanding these hidden populations too, like the ones accompanying Venus. Knowledge, in this cosmic arena, is our shield, our first and most important line of defense. This discovery leads to broader questions. Questions for all of humanity. As we become more aware of these long-term potential cosmic hazards, how should we, as a species, respond? Should we invest more resources in planetary defense, exploring technologies to deflect or mitigate asteroid threats? These are not simple questions. They involve complex ethical, financial, and technical considerations. But they are conversations we must begin to have, seriously and thoughtfully. The journey of discovery continues. This new understanding of Venus's companions, it opens another window onto our solar system, its intricate workings, its hidden dangers. We invite you to reflect on these findings. What do you think should be our next steps? How can we best prepare for the long cosmic future? Please share your thoughts and perspectives. Engage with this knowledge, discuss it, and continue to explore the wonders and challenges of the cosmos. Thank you for your time.